Okay, we are up and running. Next example. Here we go. The limit as x approaches infinity of 5x plus 4 over the absolute value of x plus 5. 5x plus 4 over the absolute value of x plus 5. The plus 5 is out of the absolute value bars. We're going to be looking now at what to do when there are absolute values in a problem, and then we're going to deal with what to do when there's square roots in the problem, and then we're going to look at vertical asymptotes in a little bit. Okay? Now, procedure is exactly the same. You just got to do a little more thinking when it comes to plugging in values. So we're going to divide by the highest power of x. So we're going to get the limit as x approaches infinity of 5x over, oh, by the way, what is the highest power of x? X to the first, right? So plus 4 over x over the absolute value of x over x plus 5 over x equals. Okay, just like the other part. Now, the difference is now you've got to be very careful when you're plugging into the absolute values because that may change the sign of things. Okay, so what does the first fraction reduce to? 5. The limit as x approaches infinity of 5 plus, this does not reduce, so it's still 4 over x over, now, x is approaching positive infinity. So as you do these infinities, think about a billion as a great example of a number. So if I plug a positive 1 billion into absolute value, what sign will it come out to be? Positive, because it's absolute value. What sign will the number be on the bottom? Positive also. And so a positive over a positive will give you a positive 1. Because it's the absolute value of a billion over a billion, which is just 1. Plus, here, because we still have an x on the bottom, you don't really have to worry about that testing aspect of things. Okay, now we can just take the limit, so it will be 5 plus, what happens to 4 over x as you approach infinity? It approaches what? 0. Over 1 plus 0 also, so my answer is 5. Okay? Pretty much like just what you saw before. Agreed? Okay. Now, let's talk about what happens when it's approaching negative infinity, because that's when it starts getting a little weird. Limit as x approaches negative infinity of the absolute value of x over x minus 8. I'll scoot that up. The limit as x approaches negative infinity of the absolute value of x over x minus 8. Okay. Because we have the negative infinity involved, we're going to divide everything by the highest power of negative x. Okay, and I'm going to write that down as a reminder. Divide by the highest power of negative x. So we're going to have the limit as x approaches negative infinity. Wait just a second. The absolute value of x over negative x over x over negative x minus 8 over negative x. Because we're approaching negative infinity, we've got to now think negative 1 billion, okay? So when I put negative 1 billion into the absolute value, what do I get? A positive. So this will always be positive. If I put negative 1 billion in for the x here, after all is said and done, what sign will it be? Now remember that x is negative 1 billion. So now it's going to be positive. Do you see that? It's a double negative. So this is positive. So that means that this limit as x approaches negative infinity will be negative 1 on top. Do I need to say that again? Yeah? Okay. When I plug negative 1 billion into the top, that's positive. When I plug negative 1 billion into the bottom, it's negative 1 billion, which is positive. Okay? So what did I just say? I just messed this up, didn't I? It should be a positive one. Good catch. Good catch. Okay. So the positive over the positive should be the positive. And I'm going to edit this out of the video. Yeah. I'm going to say it one more time so that I can edit it in right. Okay? So when you put negative 1 billion in here, it's positive. When you put negative 1 billion in here, it's a negative billion, which makes it positive, and so two positives make a positive one. We're good. Okay. Now, let's be careful on the bottom. The top of the fraction will be negative 1 billion, right? Because x is negative 1 billion. X is approaching negative 1 billion. The bottom of the fraction will be positive 1 billion, and a negative divided by a positive is a negative 1. And it's 1 because it's dividing by itself. I could pick a billion or a trillion or a quadrillion or whatever. I'm dividing something by itself, but some signs are in there that are kind of weird. Now here, these two negatives can make a positive, but in the end it's not really going to matter because what's that fraction going to end up going to? Zero. Okay. So now my limit is 1 over negative 1 plus 0, which is negative 1. Questions? Yes, ma'am?
I'm just confused about the negative.
Okay. This is telling me that x is getting really close to negative infinity. So I'm going to call it, instead of infinity, I'm going to call it negative a billion. So whenever you see just an x, that's a negative billion. So anytime I see a negative x, it's a negative billion. It's a double negative next to each other. Okay, let me do it this way. This x here is negative 1 billion because it says x is approaching that number. The x on top is negative 1 billion.
When did that become a negative?
Because, no, it says x approaches negative infinity. So think, instead of negative infinity to negative 1 billion. I have an x on top. So in my mind, I'm going to plug in negative 1 billion. Okay? But here, because this is a negative infinity, I'm dividing by negative x's. So these have to be negative x's on the bottom. So now when I substitute in the negative 1 billion, that's negative 1 billion, and that's turning it positive. So I have a negative over a positive, which gives me the negative 1. Okay? Anybody else have a question? Okay. Now, let's talk about absolute square roots. Limit as x approaches infinity of 3x minus 9 over the square root of 2x squared plus 5.
I have a question.
Yes?
The negative 1 plus 8 over x, wouldn't it... I'm confused because do you include the minus into the symbol for the 8? Because it's like when you divided everything by the x. On the right side it says the limit of as x goes to negative infinity, positive 1 over negative 1.
I had this negative here over this negative here.
And
Okay.
doesn't the double negative x become positive?
Yes, but you got to realize it's 8 over a negative a billion. I mean, a negative a billion, which is really close to 0. And since 0 doesn't have a sign, it doesn't matter whether it's a negative or a positive. Okay? That's a good question. All right? Okay. Now, look at this problem. I'm back to positive infinity. I'm supposed to be dividing by the highest power of x. What do you think that is? Is it x or is it x squared? Why is it x? Raise your hand if you can tell me why it's x. What do you think, Alicia?
Because it's in the radical. It's under the radical.
Exactly, because it's under the radical. The square root of x squared is x. So that's why we're doing it that way. So we're going to divide by x to the first, or the square root of x squared for the bottom. Now what's going to happen is it's going to look different top and bottom because of the radical. And in order to simplify the bottom, I have to put it in the radical also. So here's how it's going to look. We're going to write limit as x approaches infinity. Top we're just going to divide by x. So it's 3x over x minus 9 over x. That's just like before. Over. Now we're going to put a big square root for the top and the bottom, because what we're dividing by has to be under a radical so we can simplify it. So we're dividing by x squared here, 2x squared over x squared plus 5 over x squared. Now take a look at that and see if that makes sense to you. Am I still dividing top and bottom by x? Yes, because the square root of x squared is x in this case. Okay? So now it's time to simplify. We have the limit as x approaches infinity of 3. Can't do anything with 9 over x just yet. So just leave it as 9 over x over the square root of 2 plus 5 over x squared. So far so good?
Yeah.
Okay. Now we go ahead and substitute an infinite value, so this is going to be 3. We don't write limit anymore. Minus what? 0 over the square root of 2 plus, that's going to 0 also. And it doesn't matter that it's under the square root because the square root of 0 is 0 anyway. Okay? So let's just finish this. 3 over the square root of 2, and that's done. Okay, now let's move on. I'm going to go to a new sheet of paper, and we're going to talk about vertical asymptotes, because I don't have enough room on this page to do it. You've already discussed vertical asymptotes this year in your summer review. Let's see if we can get this situated. I'll cut this out of the video. There we go. Vertical asymptotes. This is actually what's on the back of the worksheet that you got yesterday. Graphically, what does it look like? It looks like a line like this, but what's special about it? Is it a solid line?
No, it's dotted.
It's a dotted line, okay? How do you calculate a vertical asymptote if you're given a fraction equation?
Take the denominator and equal it to 0.
Set the denominator equal to 0. It is found by setting the denominator of the rational function, because that's what we've been dealing with all along here, equal to 0. It is found by setting the denominator of the rational function equal to 0. Okay, so if you have one, let's pretend like we've got one right there. You're going to be asked to do 3 things. You're going to be asked to find where the vertical asymptote is, and we just talked about how. Then I'm going to ask you to find the limit approaching from the left and the limit approaching from the right. So those are the 3 things you're going to do. Now, what happens to a graph as you approach a vertical asymptote? What does it do? It bends, and it will never cross this line, right? So it will either bend upwards or it might bend downwards. So, because those are my only two choices on the left and right hand side, the limit can only be one of two things. What's the limit going to be if it goes up? It's going to be positive infinity. If it goes down, it's going to be negative infinity. So the limit at a vertical asymptote on either side will be infinity or negative infinity. The limit at a vertical asymptote on either side will be positive infinity or negative infinity. So that's what's nice about these problems. There's only two possible answers. It's either positive infinity or negative infinity. Okay? So we're going to do a sample problem. I think we only need to do one. F of x equals 2x over x minus 6. That's the function we're going to deal with. So part A is going to say find the vertical asymptote. And I believe that you were taught that in either Algebra 2 or Pre-Calc. So what should I do to find the vertical asymptote? Set the bottom equal to 0. So x minus 6 equals 0. X equals 6 is the vertical asymptote. That was pretty simple. Now the second thing they want us to do is to find the left-hand limit and right-hand limit of each vertical asymptote. Now sometimes you will have two vertical asymptotes, so you may have to do this a total of 4 times. Now I think the verbiage that the worksheet says is describe the behavior on either side of the vertical asymptote. It's still the same thing as what's the limit as you approach it. Okay? So what we're going to do is we're going to first do the limit as x approaches 6 from the right of this function. So make sure you don't write f of x, make sure you write the equation down. Move it up some more. So the limit as x approaches 6 from the right of this function. Okay? What is the preferred method to algebraically find a limit? Any limit. Direct substitution is the first thing I always want to try. So let's do that. Let's see what happens. Well, when I plug in 6, forget the plus or minus for now, I'm going to get 12 over 6 minus 6, which is 12 over 0. Now, I had a conversation, I think, with I don't know if it was in here or the other class. Is that undefined or indeterminate? Okay, indeterminate is 0 over 0. Undefined is this. Undefined is anything but 0 over 0. Okay? Now, we're changing the verbiage just a little bit. Okay? Undefined really talks about a point somewhere. Okay? Like the tangent of pi over 2 is undefined. That's an undefined because there's an asymptote there. There is no point at that location. But limits tend to not exist. Usually you don't call limits undefined. You call them limits do not exist. I wouldn't really count it wrong. I'm just trying to talk about proper verbiage. Some college professors might get mad about it. I'm going to be pretty flexible. Okay? Now, I'm doing a limit. So this really isn't undefined here. It's actually going to be positive infinity or negative infinity because of the reasons I said on the previous video that this really isn't 0. You remember me talking about that? It's a number really, really close to 0. Now, to find out what sign it is, you went back and looked at the sign of the infinity from the previous part, right? But that's not infinity anymore, it's 6. So here's how you're going to know whether that's really a number that's a positive number really close to 0 or a negative number really close to 0. what you do is you pick a number to the right of 6 that is close to 6. Give me a number to the right of 6 that's close to 6. 6.1 is better than, say, I wouldn't pick 7. I would pick 6.1, okay? Now go back to here and look at the denominator only. What sign will the denominator be if I plug in 6.1? It'll be positive. So that tells me this is a positive number very close to 0. So I'm going to write down over here, plug in a number to the right of 6 to determine whether the denominator is positive / negative. I guess that's the easiest way to say it. Plug in a number to the right of 6 because it's 6 to the right to determine whether the denominator is really positive or negative. And in this case, it's really positive because I told you that when I plug in 6.1, that's going to be a positive number on the bottom. Now, 12 is positive. The 0 is really a tiny positive number, so this is approaching positive infinity. Let me go back and talk about this. Do you understand why 12 divided by a teeny tiny number close to 0 is positive infinity? Yes, sir.
Because that teeny number that's close to 0, I guess, because it's like the decimal is a lot smaller. So if you divide like a number like 12, a big number like that, by a super small number, it's going to end up being pretty big.
It's going to be huge. It's going to be huge. If this was 0.0000000000001, 12 divided by that, you can type in your calculator, check. It's going to be monstrously big. And the smaller the number, the bigger the infinity. That's why this is positive infinity. Okay? Now let's do the same thing for 6 to the left. 2x over x minus 6 equals. Now we're immediately substituting, so we don't need to write limit again. So it is 12 over 0. But what really is that 0? Is it a positive tiny number or a negative tiny number? Well, it says 6 from the left. Give me a decimal to the left of 6. 5.9. Plug it in the denominator only. That's the only one that really matters because the top's not going to change sign. Is that going to be a negative or a positive answer? Negative. This one's already positive divided by a negative, so this one is negative infinity. Okay, now that says that from the right hand side, I'm trying to do it in your picture, from the right hand side it's going this way, and from the left hand side it's going this way. Okay? Are they always going to be opposites of each other? Is it possible for one side to go positive and the other side also to go positive? Yeah, it's possible. So don't just assume that if this one's positive, that one's going to be negative, because it doesn't always work that way. Okay? Any questions about this? Yes, sir.
So you find out you knew the top one was positive infinity because you go to the right of 6 and then it's like 6.1.
Right.
And then that minus, and when you plug that into the function in the denominator, that results in a positive number. That's how you found
Okay. I plugged in a number to the right of 6, 6.1. Okay. When I plug 6.1, I didn't plug it into the top, but if I did, the top would still be positive, wouldn't it? Okay. The bottom is also positive because 6.1 minus 6 is a positive number. It's a positive over a positive, which gives me the positive infinity. Okay? Not necessarily that this was just a positive. You really got to look at the sign on top, because if the sign on top is negative, that would have been negative infinity.
So it's the whole.
The whole fraction. Yes, sir. The sign of the whole fraction. Okay. Anybody else have a question? Okie doke.